Hello and welcome to another video about the game of Dev. Today I'm gonna introduce to you challenge number 6. Is the lighting getting too dark already? Let me turn the light on. Does that make it better or am I now just yellow? Both. Sorry I don't have like my proper lighting setup and green screen and everything with me. I'm currently with my parents. Anyway, I wanted to make a quick video where I tell you about challenge. Why did the camera die? We don't know. Also don't have the best microphone, but it's gonna be alright. We're just gonna deal with what we have. Because I do want to show you challenge number 6. And before we do that, I want to show you the solution of challenge number 4. Because the deadline has passed and hackers who didn't manage will die now. Which means I can tell you how to solve it. So let's have a look. So challenge 4. First look at the code. Essentially we had to get past this thing. So there was a magic number 0x dead, and then we could add a number that we give into the instruction data, and then when the sum is 0 we save our hacker, otherwise we die. So that's a classic integer overflow. What do we have? Well, we have two U32s. So in order to overflow this, we need to overflow the unsigned 32-bit integer. And the way I did this, look here, I'm gonna make this a bit bigger. There, that's my solution code. Essentially, I start with the value all f's, so that's the largest value that an unsigned 32-bit integer can have. 32 bits are 4 bytes, so 1, 2, 3, 4 bytes, all set to ones. That's the largest value of a positive U32 integer. And then if I were to add 1 to this, that would overflow this value and go back to 0. So just this plus this would be 0. Obviously, we don't want to add 0. We want to add the value that then makes it 0. So we need to subtract what we have already here before. That's 0x dead. That was this magic number that was added here. So if we have the largest number minus dead plus dead, then we're again at the largest number, and then if we add plus 1, then we overflow it and we come to 0. So that's my solution code. I hope this explanation was good enough. And then essentially we just allocate those 4 bytes for that one number. We put it in, write that 32 bytes in little endian, put that into our instruction as the instruction data, send that off, and boom, our hacker is safe. Easy. In fact, almost too easy, because people are saying that it's either been too easy or just right when I ask them how difficult the challenges are. So the next challenge that I made might be a little bit harder. Just a little bit. In my opinion, it's still pretty easy. And I'm gonna turn off this Rust analyzer because I love it, but like it also makes it a bit crowded. So what do we have here? Like usually the same as usual. We have one entry point and we have that one save hacker function. That didn't really change. That's the same as we had it in the previous 3 challenges. That's what you want to have called in order to save your hacker. And it just creates a PDA with challenge 6 and your hacker mint as reference, and that's what checked. If that account exists, then you're safe. Right? That's all that does. Nothing new in here. So how do we get there? Well, it's here. So again, there's some check here. I thought, since it's the new/old meta to do like ruffles and on-chain betting games, I would do something like that, where you have the odd of, 1 in 100 to win something. So that's the chance 1 in 100, because, you know, modulo 100 gives me a number between 0 and 100, and then I check for exactly one number. I mean, I could check for zeros, right? But I was like, I'll check for 42 because that's the answer. And this random number is a U64, so to make it, you know, big enough so that we really have a almost 1 in 100 chance. If I were to just use 1 byte, then it would be a bit screwed, so I used the U64. And where do I get that random data from? Well, it's a bit complicated on chain, right? Because everything needs to be deterministic. So I just use slot hashes. And that will already be your first challenge really here, to provide the correct account. I just read the accounts like this because I can, like usually you would, you know, do it like that, and then you get a nice error message if the account does not exist, so if there's not enough accounts. And if I do it like that, then, you know, the runtime might just fail with an ugly error. But you just need to provide enough accounts, so you need to provide 6 accounts this time, and the last account needs to be this slot hashes sysvar, so this thing. And that's part of the challenge, to find out what even that is, and then provide the right thing. If you don't, then it's an invalid error and you're already stuck here. Also, I want you to provide a treasury. That's the second to last account. The treasury should be this address here, because that's an address I own, and I was like, pfft. If you don't get it right, then I will punish you. So if you have bad luck, then I'll punish you for your wrong hacking, and you'll have to pay me in this punishment. Essentially, this is just a transfer of the system program, and you'll have to pay me 0.1 sol. Yep, that's it. That's just a normal transfer, and that's the punishment. You don't want to get there. You want to go to the safe. Now, what else do I need to show you? Right, so that's the treasury. If you try to provide something else, if you try to pay yourself just, then I'm like, hey, yo, I want those funds. Don't F with me. I did that check. It's not that easy to hack, okay? Cool. Now, how do I actually get my random data? Well, this slot hashes account, I'll manually read from it. Like, I will read the 100th hash, because I mean, I can read anyone, right? Any of them will be fine. Those hashes are all essentially random data, right? So I calculate the right offset to get to slot number 100. And then I read the slot number of it, just for logging purposes, and the hash. So that's the hash of this slot that I decode from the account. And then I, print some debug messages for you. And then I actually calculate my random number based off this slot hash. I just take some random 8 bytes of the slot, byte 12 to 19. And from that, I read a U64, and that is then my random number. And if that number ends with 42, then you're lucky. So again, a 1 in a 100 chance that you're getting lucky. That's what you want to get. If you got lucky once, then your hacker is safe and you can call it a day. And that's challenge number 6. That also works. 6 fingers, complicated. Yeah, but that's the entire thing. That's the entire challenge. Now, this challenge should also teach you another thing, which is there are many ways to hack a program. There is not just one. In fact, for this particular program, I can think of 3 ways how I can hack it. And I leave it up to you which way you want to go for. In fact, I'll leave it up to the first few people to claim the easy stuff, and then I might make it a bit more difficult because, we always do like 2-week intervals. I'm thinking maybe I leave it open for the next 5 or 6 days in this version, and then I will fix some of the easy bugs, make it a bit more difficult for you to hack this. So, if you're early, it might still be easier. And that's also the same thing as in real life. The longer you wait to hack something, the harder it might get because security vulnerabilities are fixed. I might realize that something here is missing. I already realized, but I'll give you a week to find out. And because there are so many ways to hack this, I actually encourage you to talk about it, right? In my Discord, I specifically made the Game of Death spoilers chat where you can now talk about how you solve this challenge. Maybe you're thinking of something that I didn't even think of. That would be great. And, the first few people who suggest something there, maybe I'll fix whatever they come up with. Maybe not. We'll see. I'll definitely make this challenge a bit harder in a week. It will still be challenge number 6. So if you fixed it once, so if you hacked it once, then you're good. But, the longer you wait, the more difficult it is. Also, I encourage you to, try out different paths. I mean, the simplest path and the 4th version to hack this would be to, just take the loss and, just call it 100 times. And on average, after 100 transactions, if you call the program 100 times, then your hacker should be safe once. So 100 times 0.1 sol also just costs you 1 sol. So for 1 sol, you could save your hacker. Easy. Might even be cheaper. Might be a bit more expensive, depending on how lucky you are. But that's just life. There are cheaper ways. Just saying. There is cheaper, and then there is even cheaper. Just depending on how much effort you put into the hack. As in real life. Isn't that great? That's what I want you to learn with this. There's many ways to go about this. And I encourage you to try it out. Try it out by yourself first, and then go to the Discord chat where we talk about solutions. There you see some spoilers. Maybe if you're completely lost, look at some of the spoilers that other people said, and then try that. So that's challenge 5. I wish you good luck with challenge 5. I will now deploy it on the same contract because I'm cheap. I'm going to deploy it at the same address as challenge number 4 was deployed at, because you have the solution to challenge number 4 now. What's the point, right? I mean, if you want to, you can stick around and watch me deploy it live. Why not? I just need to find the right keys. Give me 1 second. That program, the update authority is GOD. Just need to find that key. No, it's not in here. Those are just the program IDs. All right, then I'll Solana config set myself to mainnet with this key that I just found. I have a bit of sol on there. Okay, cool. Should be enough to update the program. I don't need to, deploy it anew. Let's build it one more time. Build SBF, copy my challenge 3 to challenge 6 key pair. And now this target key pair is this. And if I just say program deploy, it should overwrite that. Hopefully, we'll see. Solana program deploy target deploy, and this challenge 6.so. I mean the way for all of those things, right? But it's okay. Am I making a mistake? I'm not accidentally deleting the program, hopefully. All I can lose is 1 and 1.2 sol. It's gonna be fine. Sending transactions. This is quick, unexpectedly quick. This is better slow as I would expect it from mainnet, because it was as quick as I have it with my local validator. And finalizing transaction looks good. Program deployed. So check here. Nothing changed, but the executable data. Oh, 1.336 sol. Nice. And that's less than a minute. This was updated. Okay, I think that's good. In fact, I'm gonna try it, but I'm gonna just let it fail. With my script, I don't want to show you too much. Program ID is now this. My hacker mint is this. The buffer I need to get from challenge 6 plus my hacker mint. Then I don't do this solution, obviously, but I mean, I might as well leave it here. Why not? Leave it here. And then we do the transaction with my, wait, let me remove this. My public key, this PDA, system program, then the treasury address, and the SysVer for slot hashes. And I'm just gonna send this out. So ts node run main. If I send out a transaction to this program now, attempting to get safe, what's gonna happen is it's gonna accept my transaction, but I will not be safe, but I will be punished because I didn't properly hack it, or because I was just unlucky. Well, maybe I get lucky. I have a 1 in a 100 chance. Maybe I do get lucky. Let's see. Did I get lucky? Let's check the Explorer. I prefer to look at it there. I did, of course, not get lucky, and I'm the first person to fund the treasury with 0.01 sol. That's fine as well. Oh yeah, 0.01 sol. That's true. Because 100 should get to 1 sol. That's true. It's not 0.1, it's 0.01. So it's cheap, right? You can just make a few guesses. And we will see that, I make it a bit bigger. It's the challenge 6, so the program is deployed, and we were using slot number so and so much, which had this hash, and we got this random number from it. Is my video in the way? Just about not. So we had bad luck, and we were punished, and so we, transferred some sol. Okay. So as I said, program is deployed now. You can attempt to hack it and pay less than 1 sol for getting your hacker safe. There are other ways, but the simple way is just pump out 100 transactions until you're safe. Right. And with that, I want to end today's video about the game of death. I hope that this challenge is challenging, but not too challenging and not too boring. And again, as I said, there are several ways how to hack this. You might find one way that is super easy. Try find another one that is more complicated, so I can cater all of you. There is a way to do it without paying more than just the account that you need for saving your hacker. There are ways that cost you a little bit more, but definitely not more than 0.01 sol. So that's what I want to leave you with. Check out other videos if you feel like listening to me talk some more. I will get out of this weird lighting situation now, and I will see you in the next video. Until then, enjoy the game of dev. And one more thing before I go. The challenge 5 is still going until Sunday evening. So about one more day, or maybe less, depending on when I edit this. Let me know in Discord if you're struggling with that. But yeah, it's not actually that hard. You just need to know what you're doing. And I will tell you next time how to solve that one.